name is Dr. Daniel J. Fischer, Senior Physics Consultant to the Cosmic Institute of the Known Universe. Just recently, the York County School of Technology contacted me in regards to a new event they are holding at their establishment. They implored me to employ my vast and profound intellect to illuminate the young unilluminated minds of their students. So, I will serve to instruct the students to design, construct, and demonstrate a wind-powered floating vessel that will not only be functional, but appealing. Their vessels will then be placed into competition, at which point I will compete among them. At this point, I will finally be able to attain complete and irrevocable domination!
What the?
All right then. I believe now it is time to take over the world. Let's get down to business. I began designing my sailboat with two laws of physics in mind, one of which I'm sure many of you are familiar with. The other, I'm sure the sound of will blow you away. But really, this second law is just a fancy name for something I'm sure you already know about. Law number 1 is Newton's second law, which I'm sure you know better as F equals ma. There, that's better. As for law number 2, that is the law of fluid dynamics. Don't worry, it's not as hard as it sounds. More to come on that later. Let's start with something all of you have seen, Newton's second law. In this case, when I was using it to design a sailboat, Newton says that you want to make the acceleration of the boat really big so the boat gains speed quickly. So to do this, and keep the equation balanced, you've got to make sure that the mass or weight of the boat is really small. And that's what I did. To keep the weight of the boat down, I used styrofoam, something that is very light but very strong. Well, strong for its weight. To support the sail, I used straws, because round tubes are the best shape for supporting structures that can experience stress from all directions. Now on to the laws of fluid dynamics. Since equations that follow the laws of fluid dynamics are very complicated, I only used a few rough rules of thumb to guide my boat design. The first rule says that things with large surface areas catch lots of wind and water. So what I did was design my sail to be as big as possible without disrupting my competitor's lane. This made the sail catch as much wind as possible. Then I also made for a pontoon-style boat that had very little surface area to hit the oncoming water. And now for the final rule of fluid dynamics. This rule says that sharp edges cause turbulence. And turbulence is bad in that it slows down your boat. Here, I'll show you. For the front of my boat, I smoothed out the underside so that water could easily glide under the boat. For the back of the boat, I tapered the trailing edge so that water would easily duck behind the boat. And that concludes the presentation. However, I cannot complete a major production like this without thanking a few people.